Hai everyone, kita kembali kepada lecture. Sambungan pada lecture 2, operations on sequences. So operations defining a particular discrete time system is composed of some basic operations. So you have an input sequence xn and masuk dalam system, okay, and you have the output of sequence yn. So this notation ni, please be very mindful of it. So means that kalau input saja mesti xn, kalau output saja mesti yn, okay. So always remember that, okay. Basic operations, okay. First kita ada addition operation. So adder, what happens here is that when you have an input signal goes into the summing junction atau adder, okay, it adds one sequence with another sequence and you get the output sequence. So this is your input, okay, and you akan dapat output of yn, okay. Note again, dia punya notation tu. So this is adder. Multiplication operation adalah when you insert ataupun give the input of xn into a multiplier a, okay, and your output is yn. Okay, so yn is a times xn into multiplier. Right, the next one is product modulation. Okay, is a modulator where infinite, okay, this is infinite length sequence, dia akan times with multiply with a finite sequence, okay. So this is called a window sequence, okay, window ataupun windowing, process windowing. What happens is that window ni nanti akan menjadikan infinite length sequence ni jadi finite, okay. So this is the operation, okay. Time shifting operation, okay. So you have here ada delay and then advance, okay. Most literature, many literature just refer to delay operation. So delay ni maksudnya delay dan juga advance, okay. But kita pakai dekat sini ada delay and advance, okay. So don't be confused, it's just terms penggunaan dia, nama-nama dia sahaja, Alright, so dekat sini time shifting operation. So yn, okay, adalah output apabila xn di-shiftkan beberapa unit, ya. So n is an integer, ya. Dia tak boleh jadi 1.2, 1.5. It must be 1, 2, 3, 4, 5, 6, 7 and so on, an integer number. So for a delay operation is when n adalah bigger than 0. So the unit delay is represented by z to the power of -1. So here you have the input as xn masuk dalam delay operation, dalam delay unit. So you will get xn minus 1. Okay, xn jadi xn minus 1. If n is smaller than 0, then dimasuk pada advanced unit, dia akan jadi xn plus 1. Okay, right. So this is time shifting operation. So they shift pada axis masa tu. Right, basic operation, time reversal folding operation is when we folding operation is when xn, okay, kita foldkan dia, lipatkan dia or mirror it at xn equals to at xn dipaksi n equals to 0. So all the values on this side goes to the left side. All the values on the left side goes to the right side. Okay, so it's a mirror or folding operation. Okay, so this is very simple, very straightforward. Now branching is more straightforward, but often students make a mistake here. So it is used to provide multiple copies of a sequence. So bila an input or a signal, any signal, not necessarily input, goes into a node, okay, a node, dia akan keluar sebagai signal yang sama tidak ada apa-apa perubahan yang berlaku pada signal itu. It just provides multiple copies of that particular sequence. Yeah. All right, let's look at some examples. So for any operations, addition, subtraction, multiplication, and so on, okay, you must align, it must be done on the same n. So kalau katakan kita ada x1n and then we have x2n, what we want to do any of this operation, the addition, subtraction, multiplication, division. What we have to do is, it has to be done on the same n, yeah, same n. Bila kita nak senang, we align the ends together. So 0 with 0, 1 with 1, 2 and 2, 3 and 3, and so on. Yeah. So when we have aligned these ends together, then only we operate on the xn. So at n0, kita baru tambah. Okay. x1n dengan x2n. At n1, okay, baru kita tambah x1n, x2n, okay, so and so on, okay, then you have your output. All right, so this is all the same, yeah, so you can go through the examples. Yeah, now folding ataupun time reversal ni, this is what yang saya dah terang tadi tu. Okay, so you have xn, yang this is the particular sequence that we want to fold. Okay, so we fold at this axis, this part. So when we fold, as I said before, apa yang ada di sebelah kiri kanan akan pergi ke kiri, kiri ke kanan. So you see here that the value at this at n0 tak berubah, is the same. N0, okay, n0 is the same. Okay, what you do is you just fold saja. So this one pergi ke sebelah sini. So this n1, okay, pergi ke negative n1, n2 pergi ke, as if you are folding your paper at n equals to 0. So you see that this is a time reversal. Right? Okay, now delay operation. Okay, delay operation, saya cakap tadi, when we use the term delay operation, it can also refer to advanced operation. So if so here yn equals to xn minus nd. So we have xn again, okay, with this sequence, and then nd here is nd equals to 2. So means that kita perlu delay kan kita punya xn sequence kepada delay sebanyak 2 sampel, ya, ke kanan. So delay, so we carry this, we shift this, okay. So 2 ni kita delay 2 kali, 1, 2, so here this is jadi 4 lah, okay, jadi 4. Then here we delay 2 kali, 1, 2, so we have 3, and so on, ya. Alright, so you have this delay, ya, delay. Okay. Now for advanced, this is also ND equals but to negative 2. Means they're going to shift to the left 2 samples. Okay, so that is the delay operation. Okay, let's look at something more exciting. Okay, a combinations of all these basic operations. Right, so now we have xn as the input and yn is the output. So apakah persamaan pada yn? So what is yn? So yn, if you look closely, it is a result of summation of 4 sequence, ya, 4 sequence, 1, 2, 1, 2, 3 dan 4. Okay. So for this example, you can write out the punya terms. Okay, 1 term, 2 second term, third term, and then 4th term. Okay, so here you see that at the first term, okay, you see that this xn goes into the branching unit. So apa yang keluar daripada branching unit ni adalah branching unit ni adalah branch unit okay, is the same sequence. So this is xn, okay, dan keluar daripada sini juga adalah xn. Alright, So xn darab dengan alpha 1. So you have alpha 1 times dengan xn. Okay, output dia. So here your first term ni tak ni sama dengan ya. Okay. So alpha 1, sorry. So you have alpha 1 xn. Okay. Now the second term adalah ini masuk dekat dalam delay unit xn. Bila masuk dalam delay unit, dia delay 1 kan? Bila dia delay 1, so dia jadi xn minus 1. Xn minus 1 masuk pada branching unit. So masuk pada branching unit, apakah keluaran dia? Sama juga. So here is x1n and this is also x1n. So x1n darab dengan alpha 2. So you get alpha 2, okay, xn minus 1. Okay. Now, xn minus 1 masuk pada delay unit lagi sekali. So, dia akan jadi xn minus 2. Okay. So, xn minus 2 masuk pada branching unit. So, dekat keluaran sini adalah sama juga. Xn minus 2. Di sini juga xn minus 2. So, dekat sini xn minus 2 didarabkan dengan alpha 3. Okay. So, what you get is alpha 3 xn minus 2. Okay. So, okay, sebab dia masuk sini ya. Okay. Now, ke delay unit yang seterusnya adalah masukkan kepada delay unit seterusnya adalah xn minus 2 dan output dia adalah xn minus 3. Xn minus 3 darab dengan alpha 4. So, we have alpha 4 xn minus 3. Okay. Minus 3. So, this is your output. Yeah. So, you can, this is one way of doing this. Yeah. So, that is your, right? Okay. So I will give you more examples on this so you can practice.